My name is Paulo, and I'm a professor here at Drexel. I joined here back in August of 2000, and I had the great pleasure of, being able to work with our Drexel students and to create this lab that we call the Drexel Autonomous Systems Lab. And, I'm a professor in mechanical engineering, but I work with students from the other disciplines like electrical and computer science. This area that I'm sitting in right now is a motion capture place. It has these 16 different cameras. Next to me is DRC Hubo, which we recently used for the DARPA Robotics Challenge trials in Miami back in December of 2013. And behind me is Jamie Hubo, which arrived here at Drexel back in 2008. And it was the first time this full-size humanoid was actually brought to the United States. But you could kind of contrast the differences between the two. For the event in Miami, we needed a robot that was much more stronger. I could talk a little bit more about our efforts in disaster response a little bit later. But Jamie Hubo was really engaged to really get the public excited about these full-sized robots. And we had the pleasure of showing Jamie at the Police Touch Museum, where we attracted a lot of our youth in Philadelphia, as well as the parents. And I think one of the epitomes is that Jamie threw the opening pitch at a Phillies Cup game back in, I think, April of 2012. This area, why we use the motion capture, is oftentimes we need to teach our robots how to interact with the environment, how to use the same tools that people use, touch and interact with their surroundings just like people do. And by capturing the motions that people execute in this area, we're able to map those motions into our robot, so both DRC Hubo and Jamie can learn. Okay. Another part of the lab that you don't see, which is at the opposite end, is a gantry. This allows us to do a number of very interesting things. One is that we could actually tether our humanoids onto the gantry and allow other groups outside of Drexel to both control and to monitor these humanoids over the internet. And so that's very important because it engages researchers and the public around the world to be able to use this type of state-of-the-art equipment. We also use that gantry area for other topics in our lab. For example, unmanned aerial robots or aerial vehicles. These are flying robots. And so we use that space to also design aircraft and give them the robotic intelligence to interact with the environment. Just a little bit of how Jamie Hubo actually came to Drexel is a very exciting story. Back in 2006, the national academies, as well as a lot of thought leaders, were saying that in America that we are at a disadvantage because a lot of our students are not prepared to do international collaborations. The word global is now part of the vernacular. But in 2006, some of you might remember that Thomas Friedman came out with his book, The World is Flat. This is the idea that really we have scientists and engineers around the world that are working together to address some globally important and urgent issues. And so to address that challenge, I thought that having a humanoid might be a platform that could attract American students to collaborate with the experts that are in Asia. Hubo was conceived, designed, and developed from a university in Korea called KAIST. And they are considered the world leader in the electrical and mechanical design of these robots. I suggested that America, we are still the world leaders when it comes to information technologies and artificial intelligence. And through the support of the National Science Foundation, if we could marry these two bodies of knowledge and leverage Drexel's co-op to be able to deploy our students and have them act as the agents of knowledge transfer, not only would we advance the state of the art of robots, but we would give our students that hands-on opportunity to really work in a global context. And so since 2008 until about 2012, we sent 2 Drexel undergrads to Korea, where they spent 6 months working alongside the Hubo engineers. And this is a real testament of both how co-op can play a critical difference, as well as to give our students almost a once-in-a-lifetime opportunity. It is really exciting to see our Drexel co-ops come back from overseas. A lot of them were very reluctant to leave their comfort zone. A lot of them never ever left the United States, let alone the state of Pennsylvania. And so for them to travel over 6,000 miles and to be able to work in a very foreign context brought a little bit of anxiety. But, like the Drexel tradition, they rose up to it. We didn't just drop them in there, of course. We worked with the Drexel language department, prepared them in some language training. I used spring break, where I took them for an all-expense-paid trip to Korea, where they got to get their feet a little bit wet and be able to anticipate what would be in Korea. And that really warmed them up. And now they're like global adventurers. I can't stop them from traveling. They've developed a confidence that really reflects, the pride and traditions of Drexel. So I'm really grateful to the National Science Foundation, to Drexel University, and the co-op program that really enabled our students to go there. We sent over 10 undergraduates there. Each one of them spent 6 months there. And now one of them actually returned back to Korea and is working for a company there. Others have worked with companies in the United States that have relationships with counterparts in Europe and Asia and Korea. And so I think that the co-op overseas really gave them that kind of competitive advantage, which is, in my mind today, is not an option. Our students really need to understand how to work in an international context. So back in the spring of 2012, the Defense Advanced Research Projects Agency, or DARPA, had announced something called the DRC, or the DARPA Robotics Challenge. And it was motivated because of what people observed and the lessons learned from the Fukushima nuclear reactor accident in Japan. What DARPA observed there was that there was no absence of tools or vehicles or people, but because the radiation was just so extensive and intense, they just could not send people there. And the regrettable thing was that if some valves could have been turned or switches flipped or hoses connected in the early stages of the reactor breach, then a lot of the devastation could have been mitigated. So with that, in Japan, which has worked in robotics for over 30 years, there was a real reality check here. Where were the robots and how come they weren't good enough to be able to do that type of valve turning, hose connection, and switch flipping? DARPA decided to have a challenge. It was open to groups around the world, and it required a robot to do 8 things. So it was a single robot that had to perform 8 capabilities. The first was to drive a vehicle. The vehicle had no intelligence, no sensors or robot. It was just a normal utility vehicle that you might see in a disaster site. They wanted the robot to be able to go into that vehicle and drive it. They wanted that because oftentimes ground zero and the standoff distance can be a kilometer or 2 away. And so for the robot to rapidly go there, it should be able to drive that vehicle. Okay? Also, it wouldn't have time to have driverless vehicles shipped into scene. So he said, well, robot, if it had the form and function, the first event, drive the vehicle. The second event is the rough terrain walking one. There, you can imagine that after some disaster, the area would be devastated. And so the robot would be able to walk over rock piles or vegetation or rubble. So that was the second one. The third event was that there might be debris that might be blocking doors, and so the robot would have to clear that debris. The fourth event would be to open doors. There's different types of doors: pull doors, push doors, double doors. So we wanted a robot to be able to handle that. The fifth event was that, again, inside the building, walls might be breached, and so it had to use a power tool and cut through the wall. The next event was to climb ladders, because you can imagine in these man-made structures there might be ladders or stairs that it would have to get up to. The next one, the seventh event, was to find a valve, a particular valve. It would be leaking gas or fluid. It had to turn that valve. And then the final event, number 8, was to actually connect a fire hose to a valve. So you can imagine that these 8 events present kind of a set of things that you would imagine a first responder would need to do. And so they wanted these robots to be able to try to replicate that.
So basically, we've been given 1 year to get one robot to do 8 tasks, none of which have been performed reliably by any robot ever.
We got involved with this challenge because it's critical of trying to do disaster response and humanitarian assistance.
There are 8 other university members in our team across the United States and from Korea.
And I said yes immediately because it's one of the projects that's probably going to change people's lives.
The potential for robots to replace humans in disaster situations is really amazing.
I grew up here in New York, and I think people who are from here have very special appreciation for the job that first responders do.
Because human lives are very valuable.
It means a lot, I guess, that we're actually doing something that can be applicable to the real world and something that can actually change the world for the better.
I've been amazed at seeing how people come up with different ideas, different designs to solve the same problem.
But it's also been really impressive and inspiring just to see how crazy and amazing all the teams are that have been involved in this challenge.
So in this regard, win or lose, I feel very excited and very fortunate to be involved in this competition.
Okay, so with the motivation of the DARPA Robotics Challenge, you know, when I first heard about it, I thought that this was the most craziest, most impossible challenge out there. But then I went to sleep and I woke up the next morning and I had a very strong conviction that it's something that we need to do. Not only is, you know, disaster response a very noble and important and chronic challenge that we must deal with, but as an educator, I really wanted to give our students the opportunity to be a part of history. The DRC presents 8 events that are unprecedented in the robotics community. And so for having our students being part of shaping that history was something I could not deny them. But I knew that going into this DRC challenge, I couldn't do this alone. We would be up against giants like NASA, very well-financed teams with legions of engineers. And I just did not know what we could do. But one interesting strategic advantage that Drexel has is that we have 7 of these Hubo humanoids. That was acquired by an NSF grant that Drexel has, and we use those robots to distribute them to other American universities so that we can advance the state of the art. So I thought that this might be a very good divide and conquer strategy. We would deploy each Hubo to a partner, and we would ask that partner just to work on a single event. So the analogy that I use is like, okay, here's the smartphone, and I want you to design the app. And so you could kind of see that here are the partners. We have 9 other institutions. For example, I would ask Purdue and Indiana University just to create me a ladder climbing app. Drexel worked with University of Delaware to do the driving app. And by doing this, we felt that in the 15-month, that's 15-month time frame, that we could actually have a robot that could do these 8 events. And so just listing the different teams, it was Drexel University of Delaware for Event 1, driving. It was Ohio State that was doing the rough terrain walking, Event 2. The debris clearing and the power tool wall cutting, those 2 events were given to Georgia Tech. The door opening one was attributed to Swarthmore. The valve turning was done by WPI, and the ladder climbing, as I mentioned, was done by Purdue and Indiana University, and finally the host connection was done by Columbia. It was Drexel and KAIST that managed this. We led the team. Drexel made sure that all the software would be integrated into the system, final system, and KAIST, our partners in Korea, the ones that I had deployed all my co-ops back in 2008 through 2012, KAIST would make sure they would take care of the hardware and electrical retrofits. So that was our divide and conquer strategy. This was kind of a band of brothers. It was kind of our David versus Goliath approach. That's what helped us go head to head with big boys like NASA, Johnson Space Center, or NASA Jet Propulsion Lab, as well as teams like Lockheed Martin. And it was a wonderful experience for students to have. But what was most touching, it was not just about building a cool robot. For my band of brothers here, it was about disaster response. I've worked with these groups for a while. I also lived in New York City for 7 years, and we still remember 9/11 very, very vividly. And we really wanted to know, how could we apply our engineering talents to help mitigate against those type of disasters, be it natural or man-made or, God forbid, a terrorist one. My name is Paulo, and I'm a mechanical engineering professor here at Drexel University. And our most recent project has been the DARPA Robotics Challenge. It started off in October of 2012 when teams around the world were announced as participating in this worldwide effort for disaster response robotics. So Drexel led a team that consisted of 9 other schools, and it leverages the Hubo humanoid, which was developed and designed out of KAIST, but is using a lot of the software architecture that was developed out of Drexel.
You know, robots were kind of this futuristic sort of thing, and now they're really here. They're really, you know, they're tangible. They're just about ready to be, you know, seen in everyday life, and I think that's very exciting.
There's just an enormous number of little things that people take for granted involving driving that to program a robot to do are actually, you know, journal papers and, you know, year of research kind of level problems in and of themselves.
We're really have to come up to speed in a hurry. So there's a lot that needs to get done at the same time. So we're sort of figuring out how to use the robot while we're figuring out what's the challenge going to be, while we're figuring out what the best approach is to actually solve the problem. So it's a lot all at once.
You know, these robots could actually be used for something that saves people's lives. So all of those things coming together, and that my only answer is, how do you not work on it if given the chance?
And good morning, everyone, and welcome to the 2013 DARPA Robotics Challenge here at the beautiful Homestead Miami Speedway. It's expected to be hot competition inside the garages and paddocks.
It is a collection of over a dozen of the world's top roboticists participating in a very compressed timeline to the full view of the public. Again, these were unprecedented events, but when we were out in the field, we showed that we can actually have Hubo drive the vehicle. It didn't make it to all the way to the end, but I think it opens people's eyes to see that actually we can have a robot that could drive a utility vehicle. They saw Hubo climb the ladder and made it all the way to the top, and then it slipped. But that's part of the realities that we see in robotics. They could be very finicky machines. What worked very well in the laboratory doesn't always work when there is sunlight glaring on the sensor, or there's 10-mile-per-hour gusts that blow. So it was a very positive experience. Yes, it takes an enormous amount of effort, but I think everybody that does participate grows much stronger because of it. But we're in it for the long term, and it's not just so much about this competition. You know, competitions come and go, but disasters will always be there. And so how is it do we take these lessons learned? How do we take advantage of these great opportunities for us to kick the tires of our robots? This is something that doesn't always come, and so that is something we want to keep on taking full advantage of, and continue to also be able to be amongst the best and to learn from the best, and hopefully also teach the best. I've been asked to talk about the future of Hubo, and the funny thing about talking the future is that things are happening in such a quick way that one could be quickly disproved. I mean, the technology of accelerating at such a rapid pace. I think a good way of thinking about the future is the question why companies like Google are buying up robot companies. And just my personal opinion is that I see we are entering a next phase in the revolution of information technologies. IT unquestionably has had a revolutionary impact on the global supply chain. IT has enabled groups that used to be separated are now connected through communication. Groups like suppliers, distributors, customers are now all connected to yield, build on demand or same-day delivery. The one thing that will compound on that revolution is by having robots being able to physically act on that supply chain. In other words, having robots actually do the material handling that will be necessary, be it in warehouse distribution, be it in food processing, handling poultry, meat, fish, or even agricultural harvesting, where you're dealing with specialty crops. Being able to have robots that can serve as an adjunct to work alongside or to supplement the efforts of workers would have a huge impact. Some people are concerned about, well, will robots replace our jobs? If we see what's going on in the world, again with the build on demand and same-day delivery, this is not something that you can just simply throw labor at. And this is why, even in China, we're seeing that where they have an abundance of labor, they're finding that for the quality and for the reaction to market, that they really need to have robots there that work alongside, and especially do the dull, dirty, dangerous jobs that we don't want to subject people to. I see that that's what the future is. I think I see, the DARPA Robotics Challenge was a watershed moment. This is like a Wright brothers' first flight moment. It will have ripple effects over the next 5 to 10 years and well into the future. So it wasn't just about being able to do that disaster response, but it was really about, I believe, having an impact that's going to improve the quality of life. Thanks.
All sectors report area evacuation, performing area recon for casualties and system repairs. Deploying environmental threat assessment humanoid. Navigate to containment area.
Copy.
Proceed to enter facility. Proceed to breach wall. Hubo, you're looking good. Leaking valve is in grid Alpha 1, Charlie 5. Core meltdown averted. Radioactive containment levels dropping. Return to base Kilo for decontamination.
Copy.